Have you ever really thought about how the stuff we use every day, the really complex products, goes from just an idea in someone's head to an actual physical thing? Well, a huge piece of that puzzle, that magic, happens in the world of computer-aided design. You've probably heard it called CAD. But here's the thing. It's not just for professional engineers anymore. Today, we're going to dive into how CAD is completely changing the game for learning itself. I want you to think of CAD like this. It's the digital workshop of modern industry. It's the ultimate sandbox where ideas are built, they're tested, and they're perfected, all before a single piece of real material is ever touched. This one idea is really the key to everything we're about to unpack. You see, we're smack in the middle of this massive shift called Industry 4.0. It's where the lines between the digital and the physical worlds are just dissolving. And this is so much bigger than just some robots in a factory. It's a total reinvention of how we create things, and it affects everything, from huge airplanes all the way down to the phone you might be watching this on. So that raises a huge question, right? How do we get the next generation ready for this new reality? How do we give them the tools not just to keep up, but to actually lead the way? Well, the answer, as you're about to see, lies in teaching a whole new kind of literacy. Okay, so what is CAD really? It's so easy to just write it off as another piece of software, but that's barely scratching the surface. It's actually a new way to solve problems. It's a way of thinking, a way of seeing the world through the eyes of an engineer. A really cool way to think about learning CAD is as a cognitive apprenticeship. It's like an apprenticeship, but for your brain. It's not about memorizing where all the buttons are. No, it's a guided journey where a student literally learns to think like an expert, to see the world through this lens of systems and constraints and, of course, creative possibilities. And this whole learning process really breaks down into 3 key parts. First, you've got to understand the concepts. That's the what behind the shapes and structures. Then, you need to get good with the tools. That's the how of actually using the software. But the most important part? It's developing the ability to step back and reflect on your own work, the why behind your design choices. You learn from every single virtual success and failure. And this is what makes CAD such an incredible tool in education. It is the ultimate integrator for STEM. It's like the glue that takes all these abstract ideas from science, tech, engineering, and math, and finally makes them stick together into something you can see and test. Suddenly, CAD becomes this common language that everyone in STEM can speak. That abstract geometry from math class, it's now a hands-on puzzle you can solve. Those complex molecules from science, you can grab them, turn them, and really understand them. It bridges that gap, the one between I read it in a book and I actually get it. Okay, so we've pretty much covered the why. Now let's get into the how. What does this whole thing actually look like in a classroom? Let's take a walk through the journey of one single idea as it goes from a concept to a real physical object. This journey usually follows a pretty clear 5-step path. It all starts with that spark of an idea, maybe just a doodle on a napkin. Then that sketch gets turned into a super precise technical drawing. After that, you bring all the individual pieces together in a digital assembly. And this is where the magic happens. You can test it virtually, simulate it, see if it breaks, and then finally, you bring it into the real world with a prototype. But you know what? Don't think of this as just a straight line. It's way more of a dynamic conversation. An idea from your imagination gets translated into the language of the computer, which then gets tested against the hard laws of reality. And whatever you learn from that reality check feeds right back into your imagination. It's this incredible, powerful loop. And here's what that journey actually looks like in a typical project. You can see the progression, right? Students start with the basics, sketching, and then week by week, they build on that. They move from simple models to really complex simulations, all the way until they're holding a physical, working prototype in their hands. And the impact this has, it's just profound. There was this one case where students were designing sustainable packaging, and with CAD, they could literally see the environmental cost of a bad design. All that wasted material was right there on the screen, and that made them want to go back and make it better. I mean, that's a lesson that's going to stick with you. Okay, now we get to the really fun part. How do we take these amazing digital files and actually make them real? This is where things get truly exciting. So, 3D printing, that's the ultimate bridge from the digital world to the physical one. It's what closes the loop. All of a sudden, a student's design choices have real-world consequences that they can pick up and hold. It's where theory gets a serious reality check. And in the classroom, this is an absolute game changer.
That whole design, test, redesign cycle that used to take weeks, it can now happen in a day. Students are free to explore these crazy, complex, organic shapes that were impossible before. And the applications? Well, they're endless. It connects engineering to everything from biology to art.
And hey, the data totally backs this up. One study found that classrooms using this hands-on, iterative approach saw a mind-blowing 42% improvement in how well students remembered core engineering concepts compared to just sitting through lectures. This isn't just more fun, it's just flat out more effective.
All right, let's wrap this up by looking ahead because this whole field is moving at lightning speed. We are literally watching design, AI, and manufacturing all converge in a way that is rewriting the rules of what is even possible.
And the stakes out there in the real world are just enormous. Companies that can tightly link their CAD systems with their manufacturing can slash their design to production time by as much as 60%. That is the hyper-efficient world we're preparing students to walk into. And the frontier keeps pushing further out. I mean, just imagine AI systems that don't just help you design, they actually generate thousands of optimal designs for you. Or think about 3D printing with smart materials that have electronics baked right into them. This isn't science fiction anymore. This is the next wave.
But with all of this incredible technology, we have to remember what the real goal is here. We're not just training people to use software. We are shaping a new generation of creators. People who can think critically about the problems they're solving, who can design with a real sense of responsibility, and who can help build a more sustainable future for all of us. And all of this leaves us with a really fascinating question to think about. As AI becomes a true partner in the design process, maybe even generating countless options on its own, what does it even mean to be a creator? What will be the unique role for the human mind in all of this? That's a question we're all going to be answering together.